This coefficient will depend upon the nature of contact. Meaning the contact surfaces are rough or are they smooth. If the surfaces are rough, the value would be lesser. If the contact is smooth, then the value would be lesser. If the contact is more rough, then the friction force will be more. So the value of mu will be more. So depends upon whether the surface is dry or it is wet. So depending upon how the contact surface is, the value would be defined for a particular contact surface. So each time you will be given the value of mu depending upon the surfaces. So it depends upon the nature of the contact, and the value of mu is always between 0 and 1. This is a practical observation. Obviously the value will not be negative, but the value of mu does not increase 1. And the most important thing is the friction force does not depend, or mu does not depend on contact area. It doesn't depend upon the contact area. If another block of same mass is kept like this, then the contact area is less. Even though the contact area is less, but in the formula of friction we see that the contact area does not appear. It's a constant and it's a normal reaction. Normal reaction in both the cases will be the same because mass of the block in both the cases are the same. And mu does not depend on contact area. So friction force turns out that does not depend on contact area. It only depends upon the nature of the material, nature of the surfaces in contact, and the normal reaction. We'll have a little more insight into the point number 3 as to why that should be the case, and let's discuss a little more on the cause of friction. Why at all friction is there? So see, the surfaces, no matter how smooth they seem to us, suppose this mica, this is very smooth, but on the molecular level there is always roughness. The surfaces are never perfectly smooth. So suppose there are two surfaces in contact. Suppose they are touching each other. Then the lower surface of the upper block at the microscopic level will have irregularities like this. And the upper surface of the lower block will also have irregularities like this. And when they are kept in contact, so the irregularities, the peaks, they get into each other and they forms an interlocking. Suppose this kind of interlocking exists. Now you are applying some force on the upper block for it to move, but this is not moving. The reason is it is not moving because the teeth of these irregular surfaces are locked, and unless you break this lock, it's not going to move. These are locked like this. Unless you break this lock, these are not going to move. So when you apply certain force, they press against each other. What happens is, let's consider one of the interlocking. They get pressed against each other. These two teeth get pressed against each other when you apply a little force, but it doesn't move. You increase the amount of force, and the contact is still there, but they bend. These straight teeth, they bend because of the stress that is being caused by the applied force. When you apply more force, they bend more. And then you apply more force, and then they come at the verge of breaking, and they break. Suppose these two breaks. The teeth which was there, the top of the teeth, they break. And now the upper block will be free to move on the lower surface. So unless these lockings, unless these teeth break, it does not move. And it takes minimum amount of force for these teeth to break. So the block doesn't move unless you apply some minimum amount of force. And this is what goes at the molecular level on the surface. So these are interlockings, and this is the reason why the friction force keeps on increasing as the stress keeps on building on the increasing the external force. So the friction force keeps on increasing. It is self-adjusting. You apply certain amount of force, it will resist it. You apply more amount of force, it will still resist it. You apply more amount of force, it will still resist it. And you increase the force above a minimum level, then these teeth and lockings will break, and then the body will be free to get slided on a lower surface. So this is what happens. So that's why friction exists between surface, and no matter how smooth it seems to us, at the molecular level there are always irregularities, and there are always interlockings that is existing between two contacts. Now these interlockings, how strong they are, it would depend upon how rough or how smooth the surfaces are. A smoother surface will have a smaller interlockings that will be broken easily. So this locking will be weaker for more smooth surface. For rough surface, these lockings will be much stronger, so it will require more amount of force. So the coefficient of friction for rough surfaces will be high. Now, the second thing that we are discussing, important to understand, is friction does not depend upon the contact area. As I told you that mu does not depend upon the contact area, but it depends upon normal reaction. Now, why it should depend upon normal reaction is, if the body is heavier, the lockings will be very tight. The upper surface will be seated very tight on the lower surface. So the lockings will be very strong. It will be a strong locking. So to break that strong locking, it will be difficult. So a heavier body gets seated into these lockings very strongly. So it becomes difficult for that lockings to be broken and the body to move. So of course it should depend upon normal reaction, because the strength of these locking would depend upon the upper force, how well they are seated with each other. So it should depend upon the normal reaction. Now it would not depend upon the contact area. Now let me give you a little bit of feel as to why it should not depend upon the contact area.